Okay, so welcome to this video where we are going to introduce a new topic for complex numbers, or rather we are trying to understand what complex numbers are all about. So complex numbers, one, we need to understand the following things. Let me just write the topic here, complex numbers. So what are the things that you have to understand the most under complex numbers? One, you need to know the definition of what a complex number is. If you understand the definition of a complex number, you'll find that complex number you can combine complex numbers using the following. One, you can combine complex numbers using addition. Secondly, you can also combine complex numbers using multiplication, and division. You can also have to understand mostly that complex numbers can also be dealt with using what we call absolute values of complex numbers. Then we also have the last thing, which is also connected to complex numbers. This is what we call surds. All right, so I will try to look at what complex numbers can be defined like. A complex number, if you say complex number, a complex number is a number which can be expressed in the following way. So a complex number, this is a number which can be expressed in a form of a plus b I. A plus b I. Alright, so from the definition, you are going to understand it fully to say we have two different parts. We have this part which is not having I, and the other one which is having I. How do you name these given parts over the complex number? If you have A plus bi, you find that this one is given its own name, and also this one is given its own name. So if you check the part which is combined, we call it as imaginary part. Then this part which is not even having any I, we call it as a real part. That's what complex numbers are all about. They have to be expressed in two different formats. They have to be expressed in a form of a real part and also a complex, or rather, the imaginary part. This also explains what surds are all about. It also applies to surds. If we say surds are numbers that can be expressed, or rather, those numbers that are found under the root. So it can also be like this. You can just express it like this. If you say a plus root of b, we call that this number is a surd. The same procedure we are going to be taking on this one, it will be the same thing we are going to be taking on surds. So complex numbers are made up of two different parts, a real part and the imaginary part. Now, how do you add the same complex numbers? How do you add the same complex numbers? Suppose we have been given something like this, two different numbers or two complex numbers. If you have something like this, a plus bi, then the other one is having c plus di. What you are going to understand here, for you to add these complex numbers, you add based on the real part must be added to the real part. The imaginary part has to be added to the imaginary part. So you are going to understand it fully to say if you add this and that, we are going to get a plus c. You can put this inside the brackets to separate with the complex, in the imaginary part. If you add this and that, so since I is common, you understand it fully to say you can just write it like this, say plus or say open bracket, then I'll add this plus d, then I'll put I outside the brackets to show that this is common, which is I and I, they're common, but these numbers can just be added. Meaning that under addition, sorry, if you are adding two different numbers, you end up, if you're adding two different numbers that are made up of, in short, two complex numbers, you also have an answer which is going to be a complex number. The answer you're going to get here is going to carry I, which is the imaginary part. Also, this one is going to have a real part, just like that. Okay, this also implies to sets. If you're adding sets, you find that the number you're going to get has to be in a form of a set. If you have A plus root of B, or say plus C plus root of D. So what you're going to understand, under sets, it has to come in a different way as compared to this. I know that if you have 2i, here you have 3i. It's very possible that this and that one can be added directly. You're going to have this. But under sets, if you have different numbers on the roots, you find that they can't be added. They can't be added. But these root parts that are going to be added, you say A plus C, and I'll say. So since these numbers, if this and that one are different, you are going to write these numbers separately to say B plus root of D. But if suppose this and that one they were the same, like this is a square root of 2, also that one is a square root of 2, you find that if you add this, it's one and the same, like you're saying x plus x. If you add this and that, you are going to get 2x. Same applies to the roots. If you're trying to add things having the same roots, you add them together. Here we are going to get maybe 2, then you have to put root of what? Root of 2, something like that. All right, now let's try to solve one of a simple example that I would like to give you guys. So let's try to solve this kind of example. I'll say find 4 plus 2i. I'll put this inside the brackets, plus, now say 3 plus 9i. So remember I said when adding, you add directly. This is different from multiplication. When you're adding, you add this and that one separately, this and that one separately. So if we try to add this and that, we are going to get 7. Say plus. If you add this and that, since these numbers are the same and also this one, these numbers are different, and also if you check they're all having I, you can just do like this. Say 2 plus 9, then you put I outside the brackets. So we are going to end up with 7 plus 11 I, and this qualifies to be the correct answer under addition. So suppose we had a negative for this one, I would have added just like that. I'll put negative 2 plus 9, everything inside the brackets, then I'll put I outside. Now, you guys, do you know that at university level or maybe tertiary education, we are able to find the square root of a negative number? Yes, that's very, very possible. Look at what is happening on this one and that one. You are going to understand it fully to say, if you try to multiply I and I, you are going to get a certain number. In short, if you have something like this, I square, it must be always equal to negative 1. That is, if you try to add, or rather multiply I dot, or rather multiply by I, you have to get negative 1. But if you multiply negative I multiplied by that one, you have to get 1 here. That's the thing. Mathematics and physics, they're contradicting each other. This only applies to mathematics under complex numbers. Multiplying I and I, you must get negative 1. What does it mean? Look at what this number is all about. You'll find that this I square, if we say it is equal to negative 1, meaning that I can just be equal to what? Root of negative 1 once you square root on both sides. So if they ask you to say what is the square root of negative 4, it will be very simple for you to understand to say the root of negative 4 can be found as follows. Remember I said if you're having I square, it has to give you negative 1, right? Then if you're having I, it must be equal to negative 1. So for you to find the square root of negative 4, how are you supposed to find this? You can just separate this. How are you going to separate? I'll say root of, I'll say negative 1 multiplied by 4. Follow me clearly. I've separated this. I've multiplied negative 1 multiplied by 4, so that whenever I try to multiply this, I'll get back to what? That. And if you separate this root with respect to any number which is below it, you'll find that this can just be the same as a root of negative 1 multiplied by a root of 4. So meaning that if you check what is root of negative 1, that is I. I'll put my I here. What is a root of 4? That is what? That is 2. So you can't write complex numbers like this. You have to write them like this. I'll say 2I. You only write with I in front if you're having a number again which is going to be a square root, just like that. Okay, now someone can even ask a question to say, what if you say I to the power 3? I to the power 3 is going to be equal to what? It's very simple. Just separate this, and then you are going to separate it like this. You say I square multiplied by what? Multiplied by I. Remember, if you multiply I multiplied by I, you are going to get what? You are going to get negative 1. Always, whenever you multiply I by I, you get a negative 1 as the number. Square root of negative 4, it has to give you something like this. Square root of negative 3, you separate like the way I've done it here. Meaning that if you're having square root of negative 3, say negative 3, if you separate this, you'll find that it is going to be written like this. Root of negative 1 multiplied by 3. The best way of writing this, I said, you have to separate this. Then you are going to have something like this. What is this? Root of negative 1, this is just one and same like I from this part. You come here, you write your root of 3. This is possible that you can write it like this. But if you're having a number which is not a surd, this is a surd. If you're having a number which is not a set, you have to write a number. That's when you're going to write uh, the I in front, like the way I did when I was just introducing the same topic, or rather a definition for the same topic. I said you have to write it, or it can be expressed in a form of A plus B I, something like that. Now let's try to get back to this a bit. You find that if you have written, you tried to write it like this. What is this? We say this has to be what? Equal to negative 1. Whenever you multiply I by I, you are going to get negative 1. So meaning that this is going to be negative 1 multiplied by I. We are going to get what? Negative I. What about if you say I to the power 4? What answer are you going to get? This can just be like this. You say I square multiplied by I square. A simple mathematics. What is this? This is negative 1. What is that? That is negative 1. This is going to be equal to what? 1. So if you keep on doing the same thing, you say I to the power 6, we're going to write them like this. Say I square multiplied by I to the power 4. As simple as that. What is I to the power 4? We are saying it has to give us 1. What is I square? This is going to be equal to what? Negative 1. So you just keep on doing like that. You keep on doing like that until you are going to reach at a certain instant. Now, what would be a good example that we can follow for us to easily multiply? What would be the good example that we can have for us to multiply? Let's try to look at an example. Okay, in my second example, example 2, I would like to say, I'll say find the product of two complex numbers, that is 2 plus 3I and 4 plus 5I. It's very, very possible that they can even start with this one, but what you should always understand is if they start with this one, it becomes your imaginary part because it is made up of I. This one becomes a real part. So if you are trying to multiply this and that, we're going to multiply it like this. Say 2 plus 3I. I'll put everything inside the brackets. Then we're going to have 4 plus 5. We know how to multiply these numbers. If you have something like this, how do you multiply? you find that this is going to be this multiplied by that plus this multiplied by that. Then you come to this number, say this multiplied by that and this multiplied by that. Be careful if you are multiplying a number which is having, suppose you have, maybe for instance, if we had negative 3i multiplied by 5i. Here, since this is having a negative, we'll find that if you say negative 3 multiplied by 5, we are going to get negative 15. Now, I multiplied by I, we are getting what? Negative 1. If you multiply this, you are going to get what? 15. So, always, whenever you are trying to multiply the imaginary part having a negative and the other one which is having a positive, definitely you are going to get a positive answer. But if you are multiplying both positive imaginary parts, you are going to get what? A negative number. So if you say this multiplied by that, we're going to get 8. This multiplied by that, we're going to get plus 10i. This multiplied by that, I will get plus 12i. This multiplied by that, I will get plus 15. Open. This multiplied by I am trying to multiply I and I. I'm getting negative 1. So we are going to get, that is 8 plus this and this, we're going to get 22i. Here we're going to get negative 15. If you try to add this and that, we're going to get negative 7 plus 22i. This becomes the correct answer for this same question. Let's try to look at how to divide these numbers. What concept are we supposed to follow whenever you're trying to divide these numbers? So you find that under division, division introduces a certain important concept on our side. What is that same concept? This one, it introduces a concept of conjugates. The meaning of a conjugate is to make sure that the original thing has been multiplied by the opposite. I think you've already ever heard of this word. A conjugate simply means the opposite of something which is the original thing. So if you're trying to multiply, let's say you want to have a plus bi. The conjugate of this one simply means you need to change the sign which is in the middle or on the part of what? The complex. I mean the imaginary part. If this was negative, since it is on the part of the imaginary, you have to make sure that you find its what? Its conjugate. What does it mean? If you have a plus bi, the conjugate for this one has to be a minus bi. Reason being, this is the opposite sign to what? To that one. This is the opposite sign to that one. Now, how possible is this? How can you make sure that you are doing the right thing in this case of time? You are going to understand it fully that this normally applies to the quotient of the quotient. The meaning of quotient simply means whenever you're trying to divide, whenever you're trying to do what, whenever you're trying to divide. So meaning that for you to, if this has been written in a form of complex numbers having the denominator and the numerator, always a denominator shouldn't have a complex or surd. All right, so the meaning of a denominator not having a surd or complex, it means you need to make sure that you multiply both the numerator and the denominator by the what? The conjugate of the denominator. That process is what we call rationalization of a denominator. Find maybe each, say find each of the following. Each of the following quotients. So if A has been written like 4i over 3 minus 2i, then B has been written like 3 plus maybe 5i over 4 minus I. Remember, I'm saying the denominator shouldn't be having what? A complex. number. This is the complex number because it is made up of two different parts, this one and that one. To make sure that this has been written in a proper way, the denominator should only have a real part. What are you supposed to do? You conjugate or you rationalize the denominator by multiplying this one by its conjugate. So what will be the conjugate for this one? You just have to change the sign which is in the middle. The opposite to this has to have a different sign in the middle. Okay, what does it mean if you write it like that, or maybe you say it like that? You'll find that 4I, it's very possible that this one can have the what in the complex number. That's what we normally do. So if we're having 3 minus 2I, to rationalize the denominator here, it simply means you multiply both the numerator by the conjugate for this one. Conjugate simply means having an opposite sign in the middle, which is part of what? It only affects the sign which is part of the imaginary. If this was -3, still the conjugate for this one has to be -3 plus 2I. So in this case, we're going to have plus 2I. I'll also do likewise to the denominator part. So you're going to understand it fully to say multiplication. If you're multiplying these numbers by the conjugate, if you multiply this by its opposite, it's just as good as multiplying direct to say this multiplied by that, then you say this multiplied by that. Reason being, it's very simple. If you multiply this, like you do it like the way I did previously, you understand it fully to say this multiplied by that, and then you go by this and that, they're going to be cancelled at a certain point. How? This and that, you're going to get 9. This and that, you're going to get 2I. I mean, you're going to get 6I. And then if you say this and that again, you say minus what? 6I, of which they're going to be cancelled. Just do them directly. I'll start from the numerator. I'll say this multiplied by that, I'll get 12I. Then this multiplied by that, I said if you're having a plus and a plus, you multiply numbers having this what we call the imaginary parts. It's just one and the same, like you have a negative. So this and that one are going to get -8 due to the fact that this and that they're going to give us what? A negative number. So this multiplied by that, I'll get 9. Then since this is having a negative, this one is having a positive, we are going to get a positive answer. That's the only trick part for these two questions. So you say this multiplied by that, I'll get plus what? Plus 4. So write these numbers in a proper way so that this can be on your right hand side by expressing it in a form of this. So always the imaginary part has to be on your right hand side. If this is not there, to write a complex number, you have to write your imaginary. Then you are going to put 0I. So we're going to have -8 plus 12I over, you add this, you're going to get 13. This becomes the correct answer. If we try to, okay, try this one. You try this one, then you can submit your answers at your free time, either to my inbox, whichever. You can submit this one. This is I. So to find this one, you just multiply by the conjugate for this one, and you'll be able to get it correct. What about the last part now? Okay, the last part is trying to tell us something which is also important, the part of absolute. The meaning of absolute simply means a number which is under what? The modulus. Meaning that if z was equal to a plus bi, then they tell you to say, can you find z under, the absolute of this one? This is just one and the same, like you're finding the magnitude of the resultant under vector. How do you handle that? You're going to take this one to be your x, this one to be your what? Your y. So if you are trying to find the absolute for this one, which is z like this is just going to be what? Say root of x square plus y square. This becomes your x, and here you just take b to be your what? To be your y. You're going to write it like this: a square plus b square. Simple. A good example I would like to give you is this. If they ask you to say, can you find the absolute value for maybe z, which is equal to 2 minus 3i, that is a. B, they say z, which is equal to -4i. If you check this one, it only has the imaginary part. It doesn't have the real number or the real part. Then we also have C, z, which is going to be -4. To find this one, it will be very simple. Just write like this. Say A, Z, the absolute value for this one has to be Z. It will be equal to, if you say this is your X, you're going to say 2 square plus, come to this one, I'll say negative 3 square. We're going to get 4 plus 9. This is going to be root of 13. This is the correct answer. Yeah, so even for this one, since we don't have the root part here, Z will be equal to 0 minus 4. Here we don't use my J, we only use my I. For this one, it only has the root part, it doesn't have the imaginary part. Z is going to be equal to negative 4 plus 0 I. Try to solve these questions, and you can submit answers at your free time. So this was just a simple introduction to what we call complex numbers and sets. We're going to discuss more in the next videos that I'm going to post. So mainly solving questions under sets and complex numbers. Thank you for your time.